Let's look at two compound interest examples where the investment period isn't a full number of years. In question number 1, you made a registered retirement savings deposit of $1,000 on December 1st, 2014 at a fixed rate of 3% compounded monthly. If you withdraw the accumulated amount on August the 1st, 2021, how much will you receive? To answer a question like this, you need to remind yourself of the future value of compound interest formula, which looks something like this. Future value is equal to your present value, which can be represented by the letter PV or P, multiplied to 1 plus the interest rate per period raised to the power of n, which is the total number of periods. And I can be further broken down into R divided by T, where R is the nominal interest rate. In our case, that's 3%, while T represents the compounding periods per year. For us, T will equal to 12 because it's being compounded 12 times per year, as stated here. N can also be broken down into N is equal to M times T. We already know what T is. M represents the duration. So the duration here is from December 1st, 2014 to August 1st, 2021, and we need that in years. So M needs to be in years. So we have pretty much everything we need except for M. Let's start filling things in. So again, our principal is $1,000. And in parentheses, we have 1 plus our nominal interest rate of 0.03 divided by 12. And that's being raised to an unknown value of M times 12. We need to find out how many years pass from this date to that date. So let's create a little timeline. Let's say that this is December 1st, 2014, and many years passed to December 1st, 2020. Notice that I stopped at 2020. From 2014 to 2020, that is 6 years. Now, a little bit more time passes from December 1st, 2020 to August 1st, 2021. Now, August happens to be the 8th month in the year. That is, if your year started in January. But here the timeline starts at December 1st, the year before. So we have to add an extra month. This means that from December 1st to August 1st is 9 months. So M equals 6 years and 9 months. But we need to make sure that this value is in years completely. We can't have 9 months. To represent 9 months as a year, we can write down 6 for the 6 years and 9 over 12 for the 9 months. That's how we represent 9 months in years. We can simply take 9 and divide it by 12. So this is our value of M. Now to make things simple, we can even write this as a decimal. If you divide 9 over 12, it's 0.75, so it's 6.75 years. We'll substitute that into our value of M. Now using our calculator, we'll multiply 1,000 times 1 plus 0.03 divided by 12 raised to the power of 6.75 times 12. And if you're not using a calculator like this one, you may want to put the exponents in parentheses just to prevent any sort of computation errors. We end up getting 1,224, and to 2 decimal places, 15 cents. Let's do question 2. Find the maturity value of a promissory note, which is a legally binding loan agreement, for $3,200 dated March 31st, 2019 and due June 31st, 2025, if interest is 7% compounded quarterly. So the fact that it's being compounded quarterly means that it's 4 times per year. This is our nominal interest rate, 7%. This happens to be our principal, $3,200, and all we really need is the value of M, the correct value of M. So let's create a timeline again. We have from March 31, 2019, and that goes to June 31st, 2025. So let's see how many years is from March 31st to March 31st of 2025. That can easily be calculated as 6 years. And then from March 31st to June 31st, June happens to be the 6th month of the year. March is the 3rd month of the year. So 6 take away 3 is 3 months. Altogether, M is equal to 6 years and 3 over 12, which amounts to 6.25 when converted as a decimal. So we found our value of M. Let's now substitute this into our formula. FV is equal to our principal of 3,200, 1 plus our nominal interest rate of 0.07 divided by 4. M is 6.25 and T is 4. When we multiply this all out, we get 3,200, 1 plus 0.07 divided by 4, raised to the power of 6.25 times 4, and we should end up with our final future value of 4,937.54. If you have any further questions about this concept, please leave it in the comment section below. Thank you for watching.